Ground fault circuit interrupters, also known as GFI, safeguard against electrical shock by detecting imbalances in current flow between hot and neutral wires. Traditional GFI are not suitable for motors because motors do not require a neutral wire. There are two main options for providing GFI protection for motors. Firstly, a motor protection circuit breaker, also known as an MPCB, and secondly, a ground fault trap module, also known as a GFTM. An MPCB is specifically designed for motors monitoring current flow and tripping upon detecting imbalances, similar to a GFI. A GFDM is an accessory installed with regular circuit breakers or motor starters, monitoring motor current and tripping on imbalance detection. During installation, the MPCB or GFDM must be placed on the load side of the circuit breaker panel, between the circuit breaker and the saw. For the MPCB, a neutral connection is unnecessary, whereas the GFTM requires a neutral connection for proper function. The saw should have male and female plugs and receptacles compatible with the MPCB or GFTM. The recommended option for providing GFI protection on a 220-volt wet table saw is to utilize a motor protection circuit breaker or MPCB, as it does not require a neutral connection and is specifically designed for motors. Let's delve into the technical aspects of each solution to understand why the MPCB is often preferred. The MPCB functions by continuously monitoring the current flowing to the motor. It's engineered to detect any deviation from the expected current balance which can occur if a ground fault develops. A ground fault happens when current unintentionally flows to ground, often through a person touching a live part of the equipment. The MPCB has sophisticated sensors that quickly recognize even smaller imbalances in current. When a ground fault is detected, the MPCB trips, interrupting the circuit and cutting off power to the saw. This rapid response is crucial in preventing electrical shock. Unlike standard circuit breakers, which primarily protect against overloads and short circuits, the MPCB is specifically designed to detect ground faults, making it ideal for protecting equipment used in wet or damp environments. The GFTM, on the other hand, is an add-on device that works in conjunction with a standard circuit breaker or motor starter. It also monitors the current flowing to the motor, but it relies on the existing circuit breaker for overcurrent protection. The GFTM requires a neutral connection to function correctly, as it needs to measure the current flowing back to the source. This can be a disadvantage in situations where a neutral wire is not readily available or easily accessible. When the GFTM detects a ground fault, it sends a signal to the circuit breaker to trip, cutting off power to the saw. While the GFTM can provide ground fault protection, it is not as integrated or as specifically designed for motor protection as the MPCB. When selecting between an MPCB and a GFTM, several factors should be considered. Firstly, the availability of a neutral connection. If a neutral wire is not present, the MPCB is the only viable option. Secondly, the level of protection desired. The MPCB offers more comprehensive protection, as it is specifically designed for motor applications. Thirdly, the cost. MPCBs tend to be more expensive than GFTMs, but the added protection they provide can be worth the investment. The installation of either an MPCB or a GFTM should be performed by a qualified electrician to ensure that it is done correctly and safely. The electrician will need to follow the manufacturer's instructions and any applicable electrical codes. The electrician will also need to verify that the device is properly grounded to provide effective ground fault protection. In addition to installing an MPCB or GFTM, it is important to follow safe work practices when using a wet table saw. This includes wearing appropriate personal protective equipment, such as rubber gloves and eye protection, and inspecting the saw before each use to ensure that it is in good working condition. It is also important to keep the work area clean and dry to reduce the risk of electrical shock. Regular maintenance of the saw is also essential. This includes checking the power cord for damage, inspecting the blade for wear, and lubricating moving parts. By following these safety precautions, you can minimize the risk of electrical shock and other hazards associated with using a wet table saw. Now let's consider the specific requirements of the 220-volt wet table saw mentioned. This saw operates on 2 hot wires and a ground, without a neutral. This configuration makes the MPCB the more suitable option as it does not require a neutral connection. The MPCB can be directly installed in the circuit breaker panel, replacing the existing circuit breaker. The wiring involves connecting the two hot wires and the ground wire to the MPCB following the manufacturer's instructions. The MPCB will then monitor the current flowing to the saw and trip if a ground fault is detected. The selection of the appropriate MPCB is crucial. The MPCB must be rated for the correct voltage and current of the saw. It must also have the appropriate tripping characteristics for motor protection. The manufacturer's specifications should be consulted to ensure that the MPCB is compatible with the saw. Once the MPCB is installed, it is important to test it to verify that it is functioning correctly. This can be done by using a ground fault tester. The tester will simulate a ground fault and verify that the MPCB trips. If the MPCB does not trip, it may be defective and should be replaced. In summary, providing GFI protection for a 220-volt wet table saw requires careful consideration of the available options and the specific requirements of the saw. The MPCB is generally the preferred option as it does not require a neutral connection and is specifically designed for motor protection. However, the GFTM may be a viable alternative in some situations. Regardless of which option is chosen, it is important to ensure that the installation is performed by a qualified electrician and that the device is properly grounded and tested. Remember, electrical safety is paramount. Taking the necessary precautions to protect against ground faults can prevent serious injury or even death. Understanding the technology behind ground fault protection is essential for ensuring a safe working environment. The principles of ground fault detection rely on Kirchhoff's current law, which states that the sum of currents entering a node must equal the sum of currents leaving the node. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing back through the neutral wire. However, if a ground fault occurs, some of the current will flow to ground, creating an imbalance between the hot and neutral currents. This imbalance is detected by the GFI device, which then trips the circuit. The sensitivity of a GFI device is typically set to 5 mA. This means that the device will trip if it detects a current imbalance of 5 mA or more. This level of sensitivity is sufficient to protect against electrical shock, as even small amounts of current can be dangerous. The response time of a GFI device is also critical. The device must trip quickly enough to prevent serious injury. The typical response time of a GFI device is 25 milliseconds or less. This is fast enough to interrupt the circuit before a person can be electrocuted. The effectiveness of a GFI device depends on proper grounding. The grounding system provides a low impedance path for fault current to flow back to the source. This allows the GFI device to detect the imbalance and trip the circuit. If the grounding system is not properly installed or maintained, the GFI device may not function correctly. Regular testing of GFI devices is essential to ensure that they are functioning properly. GFI testers are available that can simulate a ground fault and verify that the device trips. These testers should be used on a regular basis, especially in wet or damp environments. In addition to GFI protection, other safety measures should be taken to protect against electrical shock. These include using insulated tools, wearing rubber gloves, and avoiding contact with water when working with electricity. It is also important to inspect electrical equipment regularly for damage and to repair any damage promptly. Electrical safety is a shared responsibility. Everyone who works with electricity should be aware of the hazards and take the necessary precautions to protect themselves and others. By understanding the principles of ground fault protection and following safe work practices, we can create a safer working environment for everyone. Furthermore, the National Electrical Code, or NEC, provides specific guidelines for the installation and use of ground fault protection equipment. For example, NEC Section 210.8 requires GFI protection for receptacles installed in dwelling unit bathrooms, kitchens, and other areas where water is likely to be present. NEC Section 590.6 requires GFI protection for all 125-volt, single-phase, 15 and 20 amp receptacles used on construction sites. These requirements are intended to protect workers from electrical shock hazards. The NEC also provides guidelines for the selection and installation of GFI devices. For example, NEC Section 250.130 requires that GFI devices be installed in a readily accessible location. This allows the devices to be easily tested and reset. The NEC also requires that GFI devices be listed by a qualified testing laboratory. This ensures that the devices meet certain safety standards. Understanding the NEC requirements for ground fault protection is essential for ensuring compliance with electrical codes and for providing a safe working environment. Electricians and other electrical professionals should be familiar with these requirements and should follow them carefully. In addition to the NEC, other standards and regulations may apply to the installation and use of ground fault protection equipment. For example, the Occupational Safety and Health Administration, or OSHA, has regulations that require employees to provide a safe working environment for their employees. These regulations may require the use of GFI protection in certain situations. It is important to be aware of all applicable standards and regulations and to comply with them fully. Compliance with these standards and regulations will help to ensure that workers are protected from electrical shock hazards. In conclusion, ground fault protection is an essential safety measure that can prevent serious injury or death. By understanding the principles of ground fault protection, following safe work practices, and complying with applicable standards and regulations, we can create a safer working environment for everyone. Remember, electrical safety is a shared responsibility. Let's all do our part to protect ourselves and others from electrical shock hazards. To further elaborate on the practical aspects, consider a scenario where the wet table saw is used outdoors. Outdoor environments present a higher risk of ground faults due to moisture and contact with the earth. In such cases, GFI protection is even more critical. The MPCB should be housed in a weatherproof enclosure to protect it from the elements. The enclosure should be properly grounded to provide a low impedance path for fault current. The wiring connection should be sealed to prevent moisture from entering the enclosure. Regular inspections of the MPCB and the associated wiring are essential to ensure that they are in good working condition. Any signs of damage or corrosion should be addressed promptly. It is also important to ensure that the work area is properly drained to prevent water from accumulating around the saw. The use of extension cords should be minimized, as they can increase the risk of voltage drop and electrical shock. If extension cords are necessary, they should be heavy-duty and properly grounded. The extension cord should also be inspected regularly for damage. In addition to the technical aspects of GFI protection, it is important to consider the human factors. Workers should be trained on the proper use of the wet table saw and the importance of electrical safety. They should be instructed to report any electrical hazards immediately. The work area should be well lit and free of obstructions. This will help to prevent accidents and injuries. Workers should be encouraged to ask questions if they are unsure about any aspect of electrical safety. A culture of safety should be promoted in the workplace. This includes encouraging workers to look out for each other and to report any unsafe conditions. By addressing both the technical and human factors, we can create a safer working environment for everyone. Ground fault protection is not a substitute for safe work practices. It is an additional layer of protection that can help to prevent serious injury or death. It is important to follow all safety rules and procedures when working with electricity, even when GFI protection is in place. Remember, electrical safety is a shared responsibility. Let's all do our part to protect ourselves and others from electrical shock hazards. Consider also the long-term maintenance of the GFI protection system. Over time, GFI devices can degrade due to exposure to moisture, dust, and other environmental factors. Regular testing of the GFI devices is essential to ensure that they are functioning properly. The testing should be performed by a qualified electrician using a GFI tester. The GFI tester will simulate a ground fault and verify that the device trips within the specified time. If the GFI device fails to trip, it should be replaced immediately. In addition to testing the GFI devices should be visually inspected for any signs of damage or corrosion. Any damaged or corroded devices should be replaced immediately. The wiring connections should also be inspected to ensure that they are tight and secure. Loose wiring connections can cause arcing and overheating, which can lead to a fire. The grounding system should be inspected regularly to ensure that it is properly installed and maintained. The grounding system provides a low impedance path for fault current to flow back to the source. If the grounding system is not properly installed or maintained, the GFI devices may not function correctly. The maintenance of the GFI protection system should be documented. This documentation should include the date of each inspection, the results of the testing, and any repairs or replacements that were made. This documentation will help to ensure that the GFI protection system is properly maintained over time. By following a regular maintenance schedule, you can help to ensure that the GFI protection system will function properly when it is needed most. Ground fault protection is a critical safety measure that can prevent serious injury or death. By taking the necessary steps to maintain the GFI protection system, you can help to ensure that it will protect you and others from electrical shock hazards. Finally, consider the advancements in GFI technology. Newer GFI devices are now available that offer enhanced features such as self-testing and remote monitoring. Self-testing GFI devices automatically test themselves on a regular basis and provide an indication if they fail. This eliminates the need for manual testing, which can be time-consuming and expensive. Remote monitoring GFI devices can be connected to a central monitoring system that provides real-time information on their status. This allows for proactive maintenance and can help to prevent unexpected failures. These advanced GFI devices can provide an added level of safety and reliability. However, they also tend to be more expensive than traditional GFI devices. When selecting a GFI device, it is important to consider the specific needs of the application and the available budget. It is also important to choose a GFI device that is listed by a qualified testing laboratory. This will ensure that the device meets certain safety standards. As GFI technology continues to advance, we can expect to see even more innovative features in the future. These advancements will help to make electrical safety even more effective and reliable. Ground fault protection is an evolving field. Staying up to date on the latest advancements will help to ensure that you are using the best possible technology to protect yourself and others from electrical shock hazards. By embracing these advancements, we can create a safer working environment for everyone. The initial question about the OSHA fine highlights the importance of adhering to safety regulations. OSHA has specific requirements for GFI protection on construction sites, particularly for equipment used in wet or damp locations. Failure to comply with these regulations can result in fines and other penalties. It is the responsibility of employers to ensure that their employees are provided with a safe working environment. This includes providing appropriate GFI protection for all electrical equipment. Employers should also train their employees in the proper use of electrical equipment and the importance of electrical safety. Employees should be encouraged to report any electrical hazards immediately. OSHA conducts inspections of construction sites to ensure compliance with safety regulations. These inspections can be triggered by complaints from employees or by random selection. If OSHA finds violations of safety regulations, it can issue citations and fines. The amount of the fine depends on the severity of the violation and the employer's history of violations. In addition to fines, OSHA can also require employers to take corrective action to address the violations. This may include installing GFI protection, providing training to employees, or modifying work practices. Compliance with OSHA regulations is not only a legal requirement, but also a moral obligation. Employers have a responsibility to protect their employees from harm. By providing a safe working environment, employers can help to prevent accidents and injuries. The cost of compliance with OSHA regulations is often less than the cost of an accident. Accidents can result in lost productivity, medical expenses, and legal fees. In addition, accidents can damage an employer's reputation and morale. Investing in safety is a smart business decision. By creating a safe working environment, employers can improve productivity, reduce costs, and enhance their reputation. OSHA provides a variety of resources to help employers comply with safety regulations. These resources include training materials, publications, and online tools. OSHA also offers free consultation services to help employers identify and correct safety hazards. Taking advantage of these resources can help employers to create a safer working environment for their employees. In conclusion, compliance with OSHA regulations is essential for protecting workers from electrical shock hazards. Employers should be familiar with the OSHA regulations that apply to their industry and should take the necessary steps to comply with them. By creating a safe working environment, employers can help to prevent accidents and injuries. Remember, electrical safety is a shared responsibility. Let's all do our part to protect ourselves and others from electrical shock hazards. This discussion underscores the multifaceted nature of electrical safety. It's not just about installing a device, but also about understanding the underlying principles, adhering to regulations, and fostering a culture of safety.